to all, and thank you for the small routine of raising, standing up, and going to the small table. It's giving some dynamics to the subject. We will enter now the last part of the space session with this round table dedicated to trying to form a roadmap of AI for the future. So projecting ourselves in the future, and more or less, it's not yet Christmas, but asking the specialists of AI to improve things, to develop new algorithms, and to make sure that there are some, let's say, really applicable aspects for our applications. So this is, let's say, something that we'll handle with 9 people with us. So it's not that easy, but you are all representative of an important aspect of the space functions, and so we try to focus and to gather the needs. So. Hopefully, it's one of the objectives of the Air and Space Academy is to form a recommendation for policymakers, and maybe we will have a paper, or probably we will have a paper on the AI, and space needs to be represented. So it's up to us to describe what we would wish. So. I can take back my, sorry for that. I will animate this panel. Please take the microphones, and there are only 2 microphones for all, so we need to share. One in this region, and maybe the others. So. The takeaway from the previous sessions, maybe we will have to be a little bit more focused on what we mean as AI. Let's say sometimes we talk about deep learning, sometimes we talk about let's say simulated and other aspects of the thing. We never talked about knowledge-based AI, so combination of physics laws and AI as such. Maybe it was, say, I see your head moving. Let's say that's obvious to some extent, but we should be a little bit more focused if we want to have a roadmap on AI. Say, let's try to ask the specialists of AI to understand what we mean by making ourselves at their level, in their ecosystem. Today I saw, in fact, several aspects of what AI can do for us. Namely, decision-making supports. I heard several times the companion aspect, so helping the people to take decisions by trying to help them in the complexity of their life. There is another thematic which is, let's say, trying to reach more autonomy, what I would call smart and reliable automation to start with, maybe autonomy for the one in Mars, on Mars, and so why not exploring the exoplanets, and it may come one day. There is a third thematic which is faint signal detection. Say when we've got huge data sets, say data lakes, maybe not, because it's lake means that it's available, but let's say noisy things, things where, let's say, the impression is difficult to get if you are human, where maybe AI can help in order to detect the things. This applied basically for space situational awareness, and to some extent to the maintenance and the long lifetime of satellites by let's say detecting the batteries which would go battery, propulsion, whatever. And let's say maybe the last thematic is edge computing, and here in fact I meant on-board computing more than edge computing. I understood that edge computing was the computing immediately after the sensing, whatever it is, a ground system or an on-board system. So I saw these four aspects as some basic, how to say, shopping list of what we could see in the various areas. But maybe there are others. So I would like to try to do some ideation aspects, to try to start with it by having each of you proposing eventually one other, or let's say stay quiet if you think that the four thematics that we have are already sufficient, or giving some more flesh to what I proposed as the four thematics, which are more or less takeaways of what we all said. So, do you mind to do this ideation? It's again, it's a little bit Christmas list to the specialist. In fact, we've got one specialist there, Jamal. So Jamal, you should listen, because at the end, you are Father Christmas in this area.
Even worse than that. I'm going to be even worse than that, something you didn't mention.
Okay, Santa Claus? Okay. Père Fouettard, peut-être?
No, I was really thinking in the roadmap, maybe very long-term roadmap, not the short-term.
Okay.
I think these multiple systems need to become autonomous and self-organized and cooperative. I think this is really something that's going to catch up with us, whether we like it or not. And this is even true for terrestrial networks. Right now, we want to do slicing, multi-domain, multi-sectoral slicing and what have you in 6GG and what have you. And I see exactly the mirror problem in future satellite systems when there are multi-orbits, multi-systems, and they have multi-connectivity. You have to split the flows. You have to do a lot of things of that sort. So they need to cooperate, according to me, and learn how to exchange the right information and minimize the burden of doing so as well.
Okay. So I propose
that's all I see personally.
I propose to have the thematic number 2 as reliable and smart automation, with an addition which is cooperative, let's say open systems. So, let's say, is there another one?
Decision making, of course. Yeah.
Optimization and decision making topics are also very important.
So it's thematic 1. Is that okay? Yeah. You want to say, at least say, Gabriele?
Thank you. I think maybe there's an elephant in the room, in the sense that I do concur with the four streams, with the four areas, but something maybe we should pay a bit more attention to is the data. And I think when we started at ESA working on AI solutions, it was very easy to develop a proof of concept. We managed to do that in 8-10 weeks in total. Then we wanted to make it a product. That was a challenge, and it is still a challenge. And the reason for that is when you develop a proof of concept, you typically just use offline data. So you just set up the data, you pre-process it to some extent, and you eventually manage to make it in the right format for you to then demonstrate that the product you are aiming to build later on will actually generate value. But if you want to make it operational, that means in ESOC terms that you want to have live data that is streamed in near real time, and based on that you make you build your AI. And this is really complex because of the data silos that we have across missions, across systems, also because of the way each system was built, different generations, the fact that we don't necessarily want to modify a system that is working, but we just maintaining it, so we don't evolve it, we just maintaining. So I think this element that is really transversal, and it is really an enabler, is critical. And we are basically looking at this going towards a hybrid cloud, where we do have some data in-house, but also we leverage the cloud. And for me, this is a very important topic as well. I don't know. Yeah.
Okay.
I would like to go in the same direction that Gabriele at ESA. We have the same kind of problem at IGN, where in fact data having high quality and large scale data is very important point if you want to have efficient model. And maybe it could be a nice way to push for maybe large scale data sets, at least at European scale, and not only at national one, and to be able to share data sets and to share data to train better model. Because having, for instance, image recognition models that have been seen other regions from Europe and not only from France could lead to better and higher quality model. And I think the second thing that I would like to mention is more about Earth observation tasks. But some tasks are in fact way more difficult than others. For instance, change detection. So that means to be able to detect difference between two images and only the interesting change, not for instance seasonal change, is way more difficult what would be expected. And trying to have more people working on that on the long term could be a way to go through a more autonomous system, for instance, to be able to update automatically maps or database that we can use or provide in different public institutes, for instance.
One element slightly related to the two previous one is the methodology aspect that I think is important to frame for our future roadmaps and all together. Is really the notion of continuous improvement of the AI system that we developed. Traditionally, we in the space industry we deliver a system that works perfectly. It's binary, yes or no. Here we deliver a system that progresses continuously, and we have to change our mindset about that. And it is I think it's very challenging to do so. And we have to work all together on this to accept that it might not be fully perfect. That might be a problem for some critical function, but for some other functions that are not so critical, for example, for Earth observation, counting objects for Earth observation for environmental application, we might be not so perfect, but we can improve continuously. And in the end, the result will be better and much more satisfying for everyone.
Okay, let's say evolution and making sure that the operation is still maintained by the evolution. I think it is a common aspect with the military this morning. Romain?
Yeah, just wanted to highlight that indeed for to build a roadmap on AI, I think you need four elements. I think it's very sound to have use cases being the first one, and we can indeed group these use cases by categories like you did, Jean, and like we've done together. The three other key elements is indeed the data, the cloud computing, and then the brains. So you really have to have a vision on how you're going to give access to the data, give access to the computing power, and leverage the existing communities of scientists that are working on AI and that are specialists in this area. I was impressed by the staff at IGN working on AI, almost 70 people working, at least in your team, working on AI specifically. There are probably some sizable teams at Airbus and Thales as well, but I don't think every company in the space sector can afford having such a big team, working on these topics. So we really have to think about how to leverage existing, teams of scientists within academia, within the private sector, and work not in a silo as a community of space players, but really try to interact with the others. And with the cloud computing, I think the approach is pretty much the same. There are some initiatives on computing and giving access to having computational power accessible for space players is not self-evident. There are some big initiatives like Gaia-X, and it's important that space is on the roadmap, and we have to, if we have on the Gaia-X roadmap, and being sure that we do the right communication towards these people is a key element on our roadmap as a space community if we're interested in AI. And for data, well, data sharing is always a very tricky problem. But developing standards is always sound, because then at least you have a way to exchange data that you're eager to share. So I think that's a good starting point, and I know Isa and Fence are very active in this area.
Okay. Massimo,
No, first of all, I like to, I mean, the topic around cooperative system is something that's going to catch up on us big time. It's already coming, and absolutely it's going to be a necessity, in particular when you have system of system. Then you have then to, how is it going to work? Because I think in those systems also defense systems, how can you cooperate with a non-friendly nation? That's an interesting one. But there are one topic I'd like to raise as potentially a topic. The reason why we haven't really, we cannot, in going as fast in AI, even though we see the need, is the fact that the development of those models and feeding those models is time-consuming. It's extremely time-consuming. It's very much use case specific. Then you have to train for a use case, and then whenever you go on it, you need to have people that spend time in labeling data and all of it. Again, I don't consider myself an expert in AI. I consider myself as a super user, but really tackling how do you get a easier implementation of AI into it, because on problem that we need it will be a problem that we'll love to have it tackled.
Okay, this is part of the Christmas list, yes. Making it simple.
Making it simple.
Valentin?
What I'm going to say is it falls beneath the help in decision making you were talking about, but maybe it's an aspect that is overlooked by us professionals that we need to address, is that space is only sexy in Hollywood movies. And when you need to communicate stuff, and when you need to give elements of decision to your bosses, to people who are not from the field, but hold some stakes, hold some decision power in there, us space professionals, we usually look at dull graphs and stuff that isn't really at the right level to be read by someone who isn't from the field. And this is something, and making those, those 3D views or those graphs that are actually readable to, normal folks, is something that is very time consuming. It's exhausting. I've been doing it for some extent to communicate towards the public or towards my superiors, and it takes a lot of time. And this is something I think that AI could address, and maybe help in making those views, and maybe coming up with them, actually coming up with ways to present the data that makes it more accessible, and that makes space more accessible and easier to to touch, because it's pretty abstract, I think, for a lot of people, the way it works.
Yeah, it's okay. I don't think it was part of my decision-making support aspect, but it's a decision-making of the decision makers to be supported. Yes. Okay. Well noted. Pedagogy, training and time-consuming, cooperative. That was said several times. So thanks for the Christmas list. Nobody else? Nicole, you don't have a. Nicole first, and then you, Nicole, again.
Thank you. Yes, I think that we could also tackle the point of knowledge transfer across different domains, because at least from my point of view, we try to implement a system which are pretty unique in the challenges that they want to achieve. For example, if I look to the moon, there are some specific challenges of navigating the moon, such as a very featureless environment that I typically don't find if I read papers about autonomous navigation on ground where the cars try to avoid obstacles. So I really see the need to, that there is a lot that has already been studied, and we achieved already great result with AI, but being able to translate these results across field, and then being able to fill the gap when we meet a challenge which is specific of our application.
Agreed. I think again this is something that was resident in one of the presentation of I think it was Safran yesterday, the guy who was invisible thanks to his Christmas jumper.
Okay.
So bridging the skills and competence between the specialists of AI and globally AI and what we are tackling. We need these people to understand each other.
Yes, and I think it's extremely important. Now in this case, I was also mentioning. So if we have an algorithm which is applied to a specific field, so it will have some fine-tuning, some specific features that are really to operate, I don't know, cars in real times. But maybe on the moon I have slightly different features, and so I have to take what I can take from that algorithm, so that I don't spend a lot of time to develop everything from scratch, and then just being able to fine-tune on a different showcase. And but I totally agree that also another part which typically slow down communication is when you have two people or two groups which are extremely knowledgeable in their field, that can be AI or space, but they struggle to communicate with each other. Because they don't see the other counterpart, basically the vision of the other counterpart. So this is like there are two slightly different perspectives, probably, but knowledge transfer in the end is the key word, I think, here.
Okay, understood. Nicolas, we will try to tackle one of the themes, nevertheless, a little bit more in depth after that.
It will be a quick one, probably. I wanted to add a note on sovereignty regarding edge computing in particular. We know that the state-of-the-art hardware capabilities don't come from Europe. What we want to fly in the satellites, that could become, let's say, an issue at some point. In Thales, we work on at least abstracting the software layers and the software development toolkit with Thales homemade solutions, so that we are a bit less dependent on those constraints, or dependent on new versions of the SDK, for example. So we are trying to reduce the problem, but still at the hardware level, there will be probably some point to check. And we have companies in France, for example, Calray, I'm thinking to them, who build strong capabilities. I think we need to work more with them, and they need to work more with the space industry, so that we can have fully sovereign solutions for edge computing in the future.
As a hardware, you mean? Something that will substitute NVIDIA. Okay. Any other Christmas list compliment? So let's try to, let's say we have, let's say something like 20 minutes, not more. Now, let's try to tackle one of the themes and see together what could make it happen. What are the barriers? How to lift them to make sure that they disappear. Let's try to start with decision-making support. So I said the companions, but it's much more than the companions. It can go to the guys in the control centers. It can go to the guys in charge of an operation on the military side. We need something coming from space, adapted to their features and to their processes. So AI can bring something. Sure. Are there barriers to that? Is that already up to steam without problem? What do we need on top of what we already have in order to make it happen tomorrow? Well, tomorrow or the day after tomorrow, Jamal. Let's say. Who wants to start? Let's say. I was proposing Valentin. In fact, let's see. Sorry for that. You are the one.
It's okay. I think it's something that's been addressed in pretty much all of the panels. I haven't been to all the panels, but the data to train the algorithms. And the thing is, when I think it through at least the eyes of my field, which is space surveillance, we have a lot of data in terms of where the satellites are. We have a lot of history on that. But if you want to train an algorithm in decision making, then you need some points in history where a decision was made. And those are much more scarce. And they're pretty hard, and even worse, they're not even historized correctly most of the time. it's pretty hard to reconstruct historically what went down in a lot of situations, because we've only been, you know, the information age, it feels like we've been there for a while now, but we're still, you know, in the beginning, I think, of a great adventure. And there's a lot of data that is incomplete or not, that you cannot harness and actually use to train those algorithms and to get there to the point where the guidance that they provide is of actual value. I think this is one of the main difficulties to overcome if we want to use that kind of technology in space operations. At least that's how I perceive it from my field, which is SSA. So maybe other fields will differ.
Okay.
I think another point could be, as it has been mentioned this morning, to have more information about the uncertainty from the model. And what we observe, for instance, at IGN is like most of the time models are what we can call overconfident. That means they will be pretty sure that, okay, this is a building, for instance, whereas it's not, it's like something else, I don't know, a truck or a swimming pool. And it will say, okay, I'm pretty sure it's the case. And we maybe need to have models that will be able to say, okay, in this case, I don't really know, or I'm not really sure. And in this case, we can then send this, for instance, this image to a human operator that will be able to say, okay, that's the correct object in the images.
And quality indicator, in fact, or something like that.
Yeah, or a better calibration of the model, if you want. Yeah.
Not the same. But what you want to say is that if you advise somebody, a decision maker, to do a decision based on the output, this is a track, so this is a road, you can go through the road, the fireman can go there. You need to say as well, yes, but I'm not wrong because it's 99% true. If it is only 70%, you have to have a flag saying it's only 70%.
Yeah, so but to be able to rely on this 70%, because for now, model will provide some probability, but the probability are not. But this is. Yeah.
But this is something that the algorithms do already, or is it just to be presented? Or?
You could embed it in the output as a soft parameter.
Okay.
But for now, it's not reliable, let's say, in operational case.
It's not
Maybe
yet there.
working more about that in the research development part.
Okay, Gabriele?
Just a quick note on what has been said. Sorry, on the confidence of the prediction. So there have been very, very strong work done in IRT with confiance.ai project, etc. It's very important to mention that there is a very strong academic level in that area, and it helps a lot and to solve or reduce the problems you are describing.
Thank you. So, if I can also provide a bit of a complementary perspective, I think oftentimes people associate, or especially nowadays, people associate intelligent assistants to ChatGPT or large language models, and that's partially correct in the sense that it is nice to interact with an intelligent assistant through a normal way of conversation. So, but I think it is really important to make sure that the data that we get is sound, and therefore we also need to provide this level of confidence in the outputs that is being provided. And one of the issues with leveraging LLM, in addition to, for instance, a knowledge graph in order to produce the output, is that they also hallucinate. And this is a very challenging task where there's a lot of research going on. And not in the space sector, because I think it shouldn't be here. It should be where the top and the best AI labs are, both academia and industry. But what we can do as a space industry as a whole is to take advantage of the research that has been done elsewhere, and then try, as we are doing already. I mean, it's not new, but to continue leveraging what has been done in industry, industry and academia, to then ensure that we can always bring the state of the art. And this is linked to the point that was mentioned earlier about modularity. So the fact that we need to keep pace with the continuous improvement of the models. And the key to achieve that is by developing modular solutions where we can kind of, in inverted commas, plug and play what is state of the art and then see how it performs in our own scenario.
Okay, Romain?
Yeah, I think we all make decisions in our daily life, in our jobs. We make decisions based on the partial information, and we get advice from our environment. If we get and usually when you get an advice, I don't know if it happens to you, but me, I tend to always ask a couple of questions because I have my own bias about the matter. So I tend to not try to address all the points that lead to the recommendation that I get, but I ask a couple of questions to see what the fundamentals are, what the methodology has been, and I think this is also what's lacking for AI. I don't think we don't need a probability. We don't need a 70% or 80% or 90%. We need to know what was the data set, what was the methodology. Okay, what's level of confidence is one of the parameters. Is it 100% or is it 60%? That if I have to make a big decision, maybe I'm gonna wait and not make this decision. So yeah, I think working on. I'm a layman to AI, so I don't know the initiatives you mentioned earlier. Confidence.ai. It's probably going very much in this direction, and I think it's super important. We work at Aldoria. We work on the traceability of our data. So we want to make sure that when we deliver data to our customer, he has access to all the main steps that led to the generation of this data, and he can trace it back to the actual sensor or the external sources that were used to provide the piece of information. So
making sure that the users feel confident using the thing because there is some background to.
Yeah, exactly. As a decision maker, you always want to ask a couple of questions. Otherwise, you feel useless, right? You don't want to be told what to decide.
Nobody wants that. Yes, the last one on decision making.
Yeah, no, just one point. I think we need to be a little bit pragmatic in all of this, and I don't think we should be too scared of our shadows because at the end of the day, if a process, the way I see it, if a process helps me 90% of the time or 95% of the time, provided that the decision are not creating obviously we're not triggering a nuclear missile because of that. If at the end of the day the consequence is that I'm turning off an equipment and it shouldn't have been turned off, and then it's just a matter of turning it back on, and that process, that AI algorithm is helping me in increasing efficiency, I would use it. Then I would use it, even if again it's not 100% accurate, and then you improve with time. I think we need to be very pragmatic in looking at this.
I would agree. Maybe before Valentin, maybe I would channel it to Gabriele again. You were talking on the stage there about the ECSS adapted to AI usage. Is there something in this ECSS which is allowing this kind of? If it is 99%, it's fair enough. It's good. We take it, or.
So we do consider thresholds in the sense that these are based on the feedback by final users, and as long as the output is beyond a certain threshold, then we accept it.
Okay.
But I think the point about Massimiliano is very valid in the sense that the threshold itself should be driven also by the consequence of taking a specific action. So it shouldn't be that for everything we need 100% accuracy. So depending
for safety, 100%.
Yeah. Yes.
Okay.
I think there was a pretty interesting point that you said is that about the consequences. If something is reliable 95% of the time and the consequences are, acceptable, then you should use it. But why don't we already have self-driving cars? Because we want to be sure that those will work, right? It cannot work just 95% of the time, right? Because that 5%, some people are going to die. Safety. So same thing with space. If human lives are at stake, and you have AI behind there, you need to be perfectly sure that it's going to work 99.99999% of the time, or maybe it's going to be even more reliable that some handcrafted algorithm or a human person just making that decision. One example in my field is collision avoidance. It's somehow a very rare event, and we evaluate the risk with the probability of collision. And that probability is never 0. It's never 1 either. It's somewhere in between. And we have to accept that it's somewhere in between, and we have to set the line at where we decide that we're going to do something, and where we decide we're just going to slide for this time, And maybe it's very unlikely, but maybe there will be a collision. And we don't have to train an AI in that regard. It's going to be complicated, because most of the time it's going to see that there wasn't a collision. We didn't do anything, and there wasn't a collision. Besides the fact that there was a probability that was non-zero. So maybe it's going to get a positive feedback that, I can just do nothing, and nothing's going to happen. And for real, if we don't do any maneuver, if we don't do anything, maybe there won't be any collision for 10 years, even with the amount of object that we have right now. It's plausible.
Yeah, but we are addressing there not exactly AI. We are addressing the judgment on risk.
It's risk management.
It's risk management. And I say this is a story about the conflict, the collision potential between Aeolus and the SpaceX. Maybe it was Starlink. I don't know. Where the SpaceX guys were saying it will not collide. Don't worry. And on the other side, on the ESA side, the probability was assessed as, 10 to the minus 4, and the other one was considering that 10 to the minus 4 was 0. So they say it's a question of human interpretation of a figure, and here it's not really artificial intelligence.
Yes, but if you want to use AI as a tool in decision making in that context, then you have to be sure that those biases, that are human biases, in terms of how you're going to take that decision, you don't bake those into the AI algorithm, because then it's going to be biased and skewed the same way that the humans are, and it's something to take into account, maybe.
Okay. I think we need to conclude there. Thank you very much to all. We are a little bit in advance, but if I start another theme, we will completely explode the timing. So let's complete the thing there. Thank you very much to all. This was a little bit complex with all these in and out to the table. Thank you for your flexibility in assessing the questions. We will try to do something out of the notes I took, and I will share that with you, of course. Thank you very much, and I think we can applaud them. Huh?